Let's continue our discussion of the type integration by partial fraction. In this module, we'll take this particular example which says evaluate the integral 5x square upon x plus 1 into x square plus 4 dx. Now my dear students, let's copy the question first. Let us check the conditions of partial fraction. If I check the first condition, degree of numerator is 2, degree of denominator is 3. So we can say first condition is satisfied. Condition 2 is not satisfied. And why it is not satisfied? Very clearly mentioned here. We require linear terms, but here we have a quadratic term. X square plus 4 is not acceptable. So we can say we cannot apply partial fraction directly. But if you remember, we had written, and it is right in front of us here, there are two exceptions. And this is the first exception. If I have a quadratic factor in the denominator, I have to slightly modify my partial form. This is the first exception. As per this, I have to take a partial fraction, or the partial form has to be slightly modified. Let's see that modification. I'll write this as 5x square upon x plus 1 into x square plus 4 will be written as a upon x plus 1, so that the linear factor gets the normal standard treatment. X square plus 4 is the quadratic factor, so you will change the numerator of it, and that will be replaced by bx plus c. So bx plus c upon x square plus 4 is the new thing we are learning here. Now my dear students, again we have to find the value of a, b and c. For that we will have to take LCM. So let's take LCM. What we get is 5x square is equal to a into x square plus 4 plus bx plus c into x plus 1. Is that okay? Now how do we find the values of a, b and c? In such a case, it is the easiest to find the value of a. That can be done if I make the coefficient of bx plus c equal to 0, and that is nothing but by using x plus 1 equal to 0. If x plus 1 is 0 means x is minus 1. So let us substitute x as minus 1. We get 5 into minus 1 square is equal to a into minus 1 square plus 4. The remaining terms will be multiplied with 0, so they are as good as redundant. So can I say 5a is equal to 5, or can we say a is equal to 1? Perfect. Now, the next value will be obtained by putting x equal to 0. Come what may, the second value to be used is always x equal to 0. So we will put x is 0, and since after putting x equal to 0 we will require the value of a, we will put the value of a as well. So what we will get on the left hand side is a 0. On the right hand side, can I say a into 4 is what I will get, wherein a is nothing but 1. So 1 into 4, and on the remaining terms I will have b into 0 plus c multiplied with 0 plus 1. That is nothing but, can I say we have 4 plus c equal to 0, that is c is equal to minus 4. We've got the value of a, we've got the value of c. Now to find the value of b, we have to use some value of x as well. We have used x equal to 0, we have used x is equal to minus 1. So for simpler calculation, I can think of the number x is equal to 1. So let us put x is equal to 1 for simplicity of calculation. Again we will require the values of a and c. So let us write that now. 5 into 1 square, so 5 is equal to a. What is the value of a? A is 1. So 1 into bracket 1 plus 4 plus b into 1 minus 4 into brackets 1 plus 1. Correct? So can I write 5 is equal to 5 plus b minus 4 into 2? Can I say 5 and 5 cancel out, and therefore can I say b minus 4 is equal to 0 or b is equal to 4? We've got the value of b, we know the value of a as well and c as well. The partial form required the value of a, b and c. We have managed to do that. So let us continue further. Let us write the partial form. So 5x square upon x plus 1 into x square plus 4 will be written as, can I say 1 upon x plus 1 plus 4x minus 4 upon x square plus 4. Now let's go to integrate. So the integral will become equal to 1 upon x plus 1 plus 4x minus 4 upon x square plus 4 dx. Let's take the integral further. So let's separate the terms. What we'll get is integral of 1 upon x plus 1 dx plus 4x upon x square plus 4 dx minus of 4 upon x square plus 4 dx. Now let us write in the next step, it is equal to integral 1 upon x plus 1 dx Now, if I check the denominator, it is x square plus 4. The numerator is 4x. Difference in the degree is 1. So, we will adjust the derivative. And derivative of x square is nothing but 2x. So, we will write this as plus 2 into 2x upon x square plus 4 dx. Correct? Plus 2 integral 2x upon x square plus 4 dx. Minus 4 is a constant. So, minus 4 integral. Can I say 1 upon x square plus 2 square dx? Correct? So, let us write further. It is equal to what? Log mod of x plus 1 plus, now this integral here, second integral, is of the form f dash x upon f of x. So, plus 2 log mod of x square plus 4 minus 4 into 1 by 2 tan inverse of x by 2 plus c. There is some simplification possible. Log mod of x plus 1 plus 2 times log mod of x square plus 4 minus 2 times tan inverse of x by 2 plus c.